Good morning everyone. Today I will be talking about correlation coefficient, an important concept in statistics. This topic helps us understand how two variables are related to each other. It is widely used in research, economics, educations, and many real life situations. In introduction part, we will discuss about the definition of correlation coefficient. Correlations measure the strength and the directions of relationship between two variables. For examples, how we study hours relate to marks or how income relates to spending. It is an important statistical tool used in data analysis and research. However, correlations only shows relationship, not cause. Correlations tell us how variables move together. If one variable changes, correlation shows whether the other variables change in a similar or opposite way. An important point to remember: correlation does not imply causation. The value of correlation always lies between -1 and +1. The correlation coefficient, denoted by R, is a numerical measure of correlation. If R equal to +1, it shows perfect positive correlation, and if R equal to -1, it shows perfect negative correlation. If R is 0, there is no linear relationship between variables, but there exists some other relationship like curvilinear relationship between variables. For examples, if y equal to x square, then there does not exist the linear relationship, but there exists another relationship between x and y. Now we will talking about the types of correlation. There are three main types of correlations. First is positive correlation, negative correlation, and last is zero correlation. Let us understand each type with examples. Positive correlation. In positive correlation, both variables move in the same directions. One increase, the other also increase. A common example is height and weight. As height increases, weight generally increases too. And it is, see, you can easily see in the graph here, on the x-axis is height and y-axis is weight. As height is increases, weight is also increases in upward direction. Next is negative correlations. In negative correlations, variables move in opposite directions. When one variable increases, the other decreases. A classic example is price and demand. As in the graph, we can see that as the price increases, demand is decreases. And next is zero correlation. Zero correlation means there is no linear relationship between variables. Change in one variable do not affect the other. For example, shoe size and the intelligence have no relationship. Now, the numerical formula for correlation is given by Pearson, which is R equal to summations of x minus x bar into y minus y bar upon under root summations of x minus x bar whole square into summations of y minus y bar whole square. And the numerical values of R is, if it is 0.8 to 1, indicate strong correlation, and 0.5 to 0.8 shows moderate correlation. 0 to 0.5 indicate weak correlation. The same interpretations applies for the negative correlation. Now we will discuss about the uses of correlation. Correlation is used in prediction and forecasting. It helps in research and data analysis. It supports decision making in business, economics, and education. And next slide, we will discuss about the limitations of correlations. Correlation does not establish cause and effect. It only measures linear relationship. Extreme value or outlier can affect correlation result. There are some real life applications in economics, correlation studies income and expenditure. In education, it relates study time and performance. In business and marketing, it helps analyze sales and advertising. And this is the summary of all the presentations. And thank you for your attention.